Okay, the type of question that we're going to be working with for the next few days is we're going to be basically doing these little proofs. And the proofs are going to be like taking this one expression and making it, showing that it's the same as this expression over here. It's kind of like when we did simplifying rational expressions. We took this kind of ugly thing, we factored it, we started dividing out those binomials that were identical, and we had this nice new thing in the end that was a little smaller. So that's all this is kind of doing. We're just phrasing it different. We're saying prove this identity, which means prove that this statement is the same as this statement. I say prove that that thing is equal to that thing. In order to do that, we have to kind of just simplify it, and that's all we do. Okay. So when we do that, usually what we would do is start with, say, one side and clean it up so it looks like the other side. So let me do some notation here. Let's call this the left side. So I'll use ls for left side. We'll call this the right side, and that's because it's on the right side of the equals sign. This is the messy side, so we'll kind of mess this. We'll take this and we'll kind of clean it up so it looks like that. So let's start with the left side. So I'll say the left side equals 1 plus cos squared over sine squared. Okay, and so my job here is to kind of clean this up so it looks like that. And then if I do, then I've proved that this is equal to that. And what we can do is we can only use algebra, and we can only substitute known things. And that's where these identities come in. We've got these 5 key identities that we've talked about. The Pythagorean identity, that these two things added together is always 1. I've got tan is always sine over cos. I've got cosecant is 1 over sine, and sec is 1 over cos, and so on. Okay, so my job here is to clean this up. And so here's what I'm going to do. If I was adding this, and this was like a rational expression, forget that they're coses and sines. Just think about them as variables and not like terms. If I had a 1 plus this fraction, I'd want to combine them. So let's get a common denominator. So the denominator right now is a sine squared. So since it's a sine squared, this needs a denominator of sine squared. So I'm going to multiply its denominator, which is a 1, by sine squared to make it a sine squared. And if I multiply the denominator by sine squared, I have to multiply the numerator by sine squared. And so 1 over 1 is now sine squared over sine squared, and I'm adding cos squared over sine squared, which was the second fraction. Okay, so just keeping with spacing over here. Now look at this. We're going to combine, right? We now have common denominators. So I've got one denominator, which is sine squared, and let's add the numerators. Sine squared plus cos squared. They're not like terms, so we'll just write sine squared plus cos squared all over sine squared. Okay, do you see what we can do? Do you see what we can do to simplify this? Have a look over here. Sine squared plus cos squared is the same as 1. So I got sine squared plus cos squared right there on the numerator. That's the same as 1 by the Pythagorean identity. So I'm going to take that out and I'm going to replace it with the 1. So now I have 1 over sine squared. Right? Okay, so I've just substituted a known piece of information into this to simplify it. Now I have 1 over sine squared. What's 1 over sine squared? Cosecant squared. That's something that I haven't specifically discussed, but if I have if I square that, I square that, right? So if I have 1 squared is 1, sine squared is sine squared, and then if I square that, I get cosecant squared. Same with all of these, like sine squared over cos squared, that's tan squared. Okay, so I've got 1 over sine squared, that's the same as cosecant squared. And notice, I've taken the left side, kind of done some algebra, substituted a known thing, and then substituted another known thing, and I ended up with the right side, which means I've proved that that equals that. So my last statement is, I've proved that the left side of that equation equals the right side. And we've just proved that identity.